Hi everyone, my name is Jessica and today I want to talk with you about testing in JavaScript applications and specifically how we can actually test against time-dependent behavior in our JavaScript applications. And by the end of this talk, you hopefully have a better understanding of what are the common pitfalls that you might fall into if you try to do that. And also along some couple of examples we see in an Ember application and how it's handled there, we also get a better understanding on how we can apply useful patterns in any kind of test suite and in any kind of front-end tech stack for ourselves to actually make these tests pass. And before we get into the topic, just a couple of words about myself. I'm a software engineer working at Simplabs. We are a German consultancy specializing in Ember.js, Ruby on Rails, and also Phoenix and Elixir consulting. And also I'm one of the members of the Ember Learning team, so we manage everything regarding documentation and guides. And also recently we started with a newsletter that goes out weekly that keeps you up to date of what's happening in Ember. So if you're curious about that, I would highly recommend you to check it out. But now let's actually get into the topic. When we write JavaScript applications, we might actually realize we actually spend a lot of time getting our head around time-dependent behavior in our apps. Things like HTTP requests, but also handling events, user interactions, timeouts, and many, many more are just a couple of examples of asynchronous operations, time-dependent operations, any kind of behavior where we actually have to get timing right and to actually orchestrate what's happening in our app to make it work in the way it is supposed to be. And once we actually build this and get our head around, it goes all quite well. But then we actually try to write tests against that, and then we realize, oh my gosh, testing that can even be harder than actually writing the features itself. And there were already a couple of talks that actually point this out, that it's actually quite difficult sometimes for us to overcome these hurdles to write these tests and actually get kind of confident in our ability to write meaningful tests against behavior we have already created in our app. And at some point, we might get frustrated and go oh, maybe I just don't write these tests. Maybe I just guard check everything that's a little bit difficult and kind of confusing to me that is going on in my app. But what we do if we actually try to avoid writing these maybe a little bit more difficult tests in the beginning, we get very complacent and we actually make it possible for a lot of bugs to creep in our application because there are a lot of time-dependent behaviors in our app that we should make sure are actually working so we can, with confidence, also ship our product. And with that said, I would just suggest to you to kind of also cultivate the thought with me that we should just try to find out how we can actually do it. And with this talk, hopefully you get a couple of ideas and examples how this could be put into practice. But before we get into the topic, let's just do a quick sidetrack into how actually testing in Ember apps works. Because I could assume, but it's just an idea of mine, that maybe not 90% of the audience is working with Ember right now. So I think it would be nice to just see how a test in Ember looks like. Ember, Ember CLI, they both come into combination if you actually create your Ember app. Highly embrace the concept of using QUnit as the default testing framework and also embracing the QUnit API into the test. And we will see how this actually looks like in an example test. So imagine you wanted to write a test like a simple unit test or container test in Ember, which actually just means you use a specific module of Ember to test against. Then you would first of all just use the native API of QUnit to create your testing structure. The module actually helps you to wrap up any tests into a unit that you can use to actually create custom setup for a collection of tests in one go. And also the test function itself, which takes a callback where you can actually just define any kind of testing scenario or any kind of assertions that you want to create in this test. Also, the before each and the after each hooks help us really with actually doing this custom setup for a specific module. So any kind of setup that we apply here will be applied to all tests that are contained in this module. And we will see later on why this is actually quite helpful. Finally, we also want to do any kind of setup that is related to our Ember app itself. For example, Ember QUnit, a package that helps you to create QUnit tests in Ember, provides you with specific custom helpers that allow you to set up application state for your Ember app so the Ember application that you currently have in the testing environment resembles in its state the actual application you would have in the dev or in the production environment. And here, for example, the setup test helper just helps us to set up modules and instances that we need for this test to actually be available in our test case. And how this works out, if we now start to write this test case, we could, for example, use the owner API. This is also something inherent to Ember, to actually look up an instance of a service we want to test against. And once we actually have this testing instance, we can do all kinds of things and actually write our assertions. So this is something, the last part, that might be more kind of like familiar to you from your own test suite. So now we got like this quick kind of like sidetrack in, and let's actually have a look at some proper test examples and how we can achieve our test cases that assert time-dependent behavior. And let's start with asynchronous operations, because this is something we oftentimes have to deal with, especially if we work in an application that actually uses routing. So you might have a routing library that you have also installed into your app. And what it usually does is, for example, provide a context for a specific view. So any kind of like route is kind of like a contained unit with different properties or data loaded that is provided to a view. It will also handle kind of route transitions for us, but last but not least, and quite importantly for testing asynchronous operations, it will also make sure that we actually load the data that we want to present and also further modulate in our view. In the UI, this could also look like something like this. We actually have different transition states that kind of like show us where the data is currently going and if it's already loaded or not. Imagine for example, you had like a loading state with a spinner, which would just like show as long as like the data is loaded. When you, for example, send out an HTTP request to another API or like your backend. And also in the end, you would have another view where you actually have the fully rendered view of your application. And for this example, I want you to imagine that we, for example, use the GitHub API for a specific repository. And we actually want just to find out what kind of pull requests have been submitted to this specific organization. And we could, for example, use the getJSON method to actually make an HTTP request. And then this will return a promise. And once this promise is resolved, we actually get the response and we can handle further with the data. How this would work, for example, in Ember app, this could also look something like this. We could just use Ember data, the data layer that is inherent to Ember, to actually make this request. And then using the model hook, you might also have like some similar setup in any other kind of like front-end framework that you're using. We can actually also return a promise, and the route will be aware if this promise is resolved or not, and make sure that the transition and also the UI resembles the transition state for it to be completed. You can also learn more about that with the links here on the slides below. I will share it later on. So let's actually write our test. We might first of all go something like, okay, I can write my own helper. I think this should work out, so let's write a test case, write our own helper that does not much than just like setting the state of my router to a specific URL. For example, we want to assert that we go to the main route, to the main URL, and actually see if we have rendered all the list items on it. And what we could write after that, after we have set the state to the router, to the current URL, we just assert, okay, we actually have like a list item rendered, and there's also, the specific text in it. And here I also want to note I'm using like another library for actually like high-level DOM assertions, so it's like a little bit more readable. You can also check out the link later on if you want to find out more about it. But interestingly, if we write that, the test doesn't really pass. And maybe a couple of you already have an idea why this is happening. And yeah, it's right. It's because we know there's like a request going out, and we actually want to wait for that. We actually want to make sure that all the data is already loaded before we actually do our first assertion, because now the assertion is executed far too early for it to actually be true, that actually a list item is rendered and it has a text. So what we might do is maybe like use another helper, or maybe write our own that just like sets a timeout, that just waits until it actually moves on to the next assertion to actually check if we have like a list item rendered. And this kind of sometimes works actually, but then also sometimes it does not. Like sometimes you might have even like pushed this code into your code base and it's up in CI, and then your colleague comes over to you and goes like, this test sometimes fails, like you should check it out. And this is first of all due to the fact that you can never kind of assume that a network request will kind of like resolve in a certain amount of time. This is like one point. The other one is as well that set timeout itself doesn't also guarantee that something is happening at 300 milliseconds. It could also be depending on how much is currently going on in the thread. There are many other things kind of like blocking it to be executed in 300 milliseconds, so it's just like maybe executed after 1 second. And yeah, this is actually quite of like a difficult thing to do in your test. And then you might go like, oh well, let's maybe just like try to fix this brittle test with something like that, where I just like input like a super high number, right? Apart from the fact that maybe your CI will just like crash down or your testing framework times out, it also kind of like guarantees that when you do this again and again in different tests, actually your tests become like super slow. And like everyone's super annoyed, everyone goes like, this test suite runs so low, I don't want to write tests anymore. So for the sanity of your team and also your own, you actually want to make a better way around that. And this is at least an Ember world where Ember test helpers comes in. And I just want to quickly show you how they work under the hood, so you can also get a better understanding on what you can do in your own front-end tech stack that might not use Ember, how to circumvent this problem. In this instance, in this example, we can simply import the visit helper from the Ember test helpers package, and then we can use it to actually visit a route. And using the async await feature, we can easily await a promise that is returned from the visit helper to then make sure that once we actually move on to the next assertion, this promise is fully resolved, the data has been loaded, and this will actually pass. And now you might wonder, okay, where's this promise coming from? How does this actually work? All of the, not all of the, but nearly all of the helpers from the Ember test helpers package, also like DOM interaction helpers, actually will be waiting for any kind of async operations to resolve. And they all share in common that they return a call to the settled method. And the settled method itself has like some kind of bit of Ember magic into it specifically that makes it easy to actually await any kind of async behavior. And we see this in the next slide. So in the settled function, we actually will check and kind of make sure that any kind of like tracked asynchronous operations in Ember apps are not present anymore. So it will, for example, check that any items are still kind of queued in the run loop. So this is like Ember's internal event management system. Also pending timers, pending waiters, and any kind of like requests are checked if they're still present. If there's any kind of like waiter, any kind of asynchronous operation still waiting, it will call itself like kind of like reversive call of all of these checks again after every 10 milliseconds. And this actually makes sure that we have a minimal amount of time where we recheck if everything actually is already going as it should or if any kind of operation is still waiting. If actually all of the checks pass, finally, the settle function will resolve the return promise, which we can later on wait for in our test again and actually move on to the next assertion. So this is quite nice because it makes it possible for us finally to keep the test as short as possible, but also wait as long as necessary to actually move on to the next assertion. And now you wonder, okay, this is actually pretty cool, but this looks really Ember specific, and this is true. It has to do with the fact that in Ember applications, you actually have a tracking system of all these asynchronous operations, and there's like a simple way for this isSettled helper to just like check on an object that tracks all of these operations if there are any left or not. But if you are in another tech stack, you might think about a similar solution where you might check just like for example, assertion to come true. And you can also, like in a kind of like recursive manner, just like make sure that you call this function again and again to check again if it's actually working. And you could just like write your own testing helper. And it's actually quite similar to an Ember test helper you can also check out in the link below. And all it in basic kind of does is if you would write your own testing helper, is also return a promise. And you would just make sure that you get the value that your assertion returns, like either true or false, and that you would also, if actually the value of this callback would turn to be true, that you resolve the promise, and if not, like if you realize, okay, this can't be true yet, that you will just make sure to call this function again to in like maybe 10 milliseconds or 20 milliseconds to check again if it now actually returns true. And you would also want to make sure maybe with a timer or something that actually this function doesn't run forever, because it might actually be that the assertion is false, right? So you want to also have like a kind of like maximum timeout for this function until you actually reject the promise. But this kind of like in a nutshell could also bring you in this very fairy tale magic land of where you actually can just reuse this helper every time again and you don't have to worry about this asynchronous operations anymore. Many other instances where we encounter asynchronous operations are related to user interaction. And why is that? Because users might use the app in kind of like also the time-dependent manner that you might not be aware of. And also, very simply, any kind of events that are triggered by users might also trigger other async operations. Let's imagine in our demo application, we would also like to load any kind of comments to a specific pull request. The user can just click on a button, and once they click on the button, this action load comments is triggered. And what it will do, it will get like a URL that is related to the pull request from the GitHub API, and then will use a service with a fetch method to actually make a HTTP request, which will return a promise that will resolve once the data is actually back and will then set the data on the context of the component. And if we try to write a test of that, we could go something like this. First of all, we get our test subject, we render it. Like in Ember, we do it with a render helper, might be something different in your tech stack. And then we click on the load button, and then finally we actually assert that all the list items are actually rendered. And here's something also interesting that comes into play again that we haven't talked about earlier. How is it actually working out that we're doing like real requests to real API in our test environment? Because it also comes with a lot of problems. You might actually run maybe like your test suite like hundreds or maybe like 1,000 times a day, like across your team, and you don't want to spam actually like real API with this request. You also, regarding like network issues, you never know when actually this request will ever kind of like return and actually give you the data. Maybe you don't even have like network access in your test environment at all. So you want to make sure that you also can have a lever on mocking this request. And this is something where I find that test double is really useful for me, and it actually provides you with different functions and different methods that also help you to mock or to simulate the functionality of a promise that is resolved, rejected, and also like callbacks. And let's have a look how this actually might play out in our example. For example, in an Ember app, we can simply register, also using the owner API again, a service. You might also have something similar in your tech stack. And we can just like extend the native service we're already using in our app anyways with a new fetch method. And here we just pass the td function method to say, okay, we actually now make this like a function that you can later on with td when resolve actually mock. And then in our test case itself, we can just like register the service, and then using td when then resolve, we actually make sure that any time this request fetch method is called, instead of making the real HTTP request, we will resolve with td when then resolve with a list of mock comments that we have created. And once we actually do that, we can make sure that, first of all, the promise resolves immediately, but also that we avoid any kind of like real HTTP requests in our testing environment. And this is quite nice, also works very well, and I can highly recommend. And these were a couple of like asynchronous, kind of like time-dependent scenarios where you kind of like might stumble upon when you try to write tests. But one that I also found very interesting is anything that has to do with when you actually run your tests. Because I sometimes found that depending on when I run the test, it doesn't have the very same outcome. And let's imagine a scenario as that we had, for example, on our main page, something like a label that just says, what the current date of the current day of the week is. For example, in this instance, Monday, and it's currently Monday, so we write this test, it passes, and everything's good, right? And then we go like, okay, let's go home and maybe like look at the CI tomorrow again. But suddenly then it fails, right? Because we look back again and we go like, oh, you're right, it always like, actually, like my app in the testing environment already shows me like the current day, but now it's a Tuesday, and also on a Wednesday, Thursday, Friday, and Sunday, this test will actually fail. So we realized we created also another brittle test, or it's quite an extreme example, of course, right? But you might have like similar, more subtle examples actually in your test suite. But we realized that we have like now a quite brittle test that is not reproducible. And to navigate that, I find really useful, and you can also use it in any kind of app. This is not Ember specific. Timecop, or another library that actually helps you to set dates and times in your tests. And with Timecop, for example, we can just like travel to a specific time in our test and actually set it as a given. So for example, we pass the date object to it, and then we can say, okay, now it's like just Monday, our test. And using the before each and after each hooks, we can also make sure that Timecop is only installed and applied for a specific test where we actually want to have it in place, and not for other tests that might fail suddenly because we might have not thought about that. And then finally, if we actually apply this to our module, we can then just like travel through time, set the Monday, and then we can make sure at any time that we actually run this test, this will pass fine and everything's good. So this is pretty cool. And this is already the last example. I want to show you about common pitfalls and also some scenarios where you might come across time-dependent behavior being a bit difficult in tests, but I also hope that you got a better understanding of what you yourself can actually do to navigate those, and that you also realize that timing in your tests really matters, and it's totally okay to spend a bit more time on finding out how to actually alleviate that. And that I would say, yeah, have a great time at Async.js, and thank you very much.